Hello students, in this class, in this video, I'm going to show you how to solve equations that involve absolute value. But before we do that, let's go ahead and review what absolute value is. The absolute value of -3, we say is 3. And the way we think about absolute value is the distance from 0 to that number. Since we know that the distance between 0 and -3, the distance here is 3 units, right? So that's why we say that the absolute value of -3 is 3. Well, same thing happens for the absolute value of 5. Well, the absolute value of 5 is also 5. So please take a note here. Let's write a note here. We think about absolute value as the distance from 0. And so also in that note, we know that the distance is always positive. So keep in mind then that the absolute value of a number is always going to be positive because we think about it as the distance from 0. So with that in mind, let's go ahead and do our first example here. How do we simplify these expressions? Excuse me. The first thing we're going to do is simplify each of the insides of the absolute value bars. Here we're taking the absolute value of -12, which we say is a distance from 0, which is 12, minus the absolute value of 12. Well, the absolute value of 12 is also 12. So here we have 12 minus 12, which simplifies to a 0. Okay, feel free to pause this video and think about the solutions. The next one would be to simplify inside the bars first. We need to multiply that negative times that negative, which turns into a positive 10. And don't forget that we still have a negative outside. Well, the absolute value of 10 is 10, but we have a negative here that we need to carry with us. So in this case, the answer is negative, but that's because we have a negative outside. The absolute value is always positive. But again, that negative outside makes the answer negative. Now, the next one would be 2 times 5, because the absolute value of -5 is 5, minus 3 times 6. Doing multiplication before we subtract would give us 10 minus 18, which is -8. Again, the absolute value of a number is always positive. Here we get a negative only because we are subtracting a large amount. Okay? All right, keep that in mind, practice and review it. Now, example number 2, we have quite a few parts here, A, B, C, D, E, maybe. The way we solve these equations, we think about, take a look at part A. We say what number is 14 units away from 0? So on the number line, we know that from 0, we have 14 is one of the answer, and then also -14 is another answer. So we say that there are two answers, -14 and +14. So we say the value of x could be 14, or it could be -14. So think about it. In reality, what we need to do here when we have an equation involving absolute value, we need to break down the two bars into two equations with no more bars in them. So memorize this little phrase. Two bars become two equations. Whenever you see two bars by themselves, it becomes two equations, one with a positive, one with a negative. So solving the next example then is going to be just that. We have two bars, or absolute value, equals 22. So two bars turn into two equations. One with a positive 22 and one with a -22. If you don't do two equations and you solve x minus 5 is 22, you're going to get one of the two answers. And that would be incomplete, or that would be wrong, because you did not find all of the answers, you only found one of them. So please remember to break the two bars into two equations, one with a positive, one with a negative, and then solve each of these equations individually, one like two different problems from this point on. We're going to add 5 So one of the answers is 27, and we're going to add 5 here. The other answer is not negative 27. Please note that. It's negative 22 plus 5, which makes negative 17. And so here are the two answers. If we needed to plot those answers, just draw a number line. And positive 27, let's say 0 is here. You count positive 27 little marks, or you can just go here and say this is 27. A little dot represents the answer, the number 27. And then negative 17, which is shorter, of course, than 27. And so here are the two answers on the number line if we need to graph them. Okay, please pause the video and think about the solutions. But one more time, 2 bars turn into 2 equations. Memorize a little phrase, and that's how we solve absolute value functions. Look at the next one. The 2 bars turn into 2 equations. So this is going to be 2x minus 7 equal 15, or 2x minus 7 equals negative 15. Please note again, we only change the sign on the outside number. We leave the inside of the bars alone. Adding 7 to both sides to solve this equation here will give us 2x is equal to 22. And then dividing both sides by 2 will give us x is 11. That's one of the answers. Adding 7 to both sides is going to give us negative 8. Dividing both sides by 2 is going to give us the other answer, which is negative 4. Again, if you needed to plot or to graph these solutions, we say 0 is here, 11 is here somewhere, that's one of the solutions, and negative 4 is here, that's another solution. And last but not least, if you're going to solve an equation that has all the numbers outside of the bars, think about it. All the other examples I did, the bars were entirely by themselves. There were no numbers outside. So if that's the way we solve the equations with no numbers outside the bars, then we need to probably get rid of those numbers outside first. So we're going to start by adding 8 to both sides. I'm not liking this, the way it's going to work, so let me go ahead and switch it before. Let's pretend this was a positive the whole time. And so let's subtract 8 from both sides instead. Notice how I'm going to keep everything else the way it is. And this is going to give me negative 12. Dividing both sides, because now I need to isolate the bars. Let's go write that down. We're trying to isolate the bars. The absolute value bars, I mean. And so we need to divide both sides by negative 2 to get the bars by themselves. And we say that the absolute value of 5 is 6. Now we have the absolute value bars by themselves, so we're going to write this down as 2 equations. One with a positive 6, and another one with a negative 6. Subtracting 5 from both sides is going to tell us that one of the answers is 1, and the other answer is negative 11. So one more time, if you have some numbers outside of the bars, you first get rid of them, isolate the bars, and then proceed to write 2 equations. Write 2 equations so that we could get both of our answers. Really quick, so this is the end of this example, but really quick, let's say that we end up with something that looks like this: A, B, C, D, E. So if we have the absolute value of, say, x minus 9 equals negative 12, what can we say about this problem? We just said up here all the way at the top that the absolute value is the distance from 0, and the distance could never be negative. So by having absolute value entirely by itself and then a negative outside, that means there's no way we could do this, because the distance from 0 to any number is always positive, not negative. So this is a problem, so we say no solution. A problem like this would have no solution when you end up with a negative outside, and you have to make sure the bars are entirely by themselves first. Okay, please feel free to watch this video over again if you need more understanding of this. I'll see you next time.